In this video, we're going to illustrate how you can deliver mainframe change faster, more flexibly and more sustainably. To do this, we'll walk you through an automated example app dev CI/CD pipeline for a mainframe COBOL application, utilising open source and IBM products. But before we dive into the demo, I'll explain a bit about PopUp Mainframe. PopUp Mainframe is an enterprise software vendor that enables mainframe customers to deliver change faster and more cost-effectively than ever. Mainframe delivery cycles are vital, but often very inefficient because of various bottlenecks in the traditional mainframe delivery cycle. But with the help of PopUp Mainframe, these bottlenecks can be removed, enabling mainframe teams to reimagine what's possible. To demonstrate this, we'll showcase the latest PopUp Mainframe product and some of its key capabilities, including full support of a modern mainframe CI/CD pipeline, using, in this example, an IBM and open source-based DevOps toolstack, the ability to stand up and shut down a virtual mainframe in minutes, the facility to snapshot and reset instances of that virtual mainframe environment, and the ability to manage a PopUp Mainframe environment using Ansible playbooks, empowering your teams with self-service operations activities. In this example, we're going to illustrate one way of delivering mainframe application code changes, for which we're using a demo application called NextGen Bank. NextGen Bank is a simple application with a web-based UI, ZOS Connect to call the backend, which uses a typical mix of COBOL, Kix and DB2. The backend for NextGen Bank is running on a pop-up in dev test, but in a real-world scenario in production it would be on a physical mainframe. But before we start, the first thing we'll need to do is stand up a virtual mainframe environment to use. So to do that, let's invoke an instance of the PopUp Mainframe product, or PopUp for short. Here you can see PopUp X Edition being stood up in Azure Cloud. We have two types of PopUp, the X Edition, which is for x86 hardware in the cloud, and the Z Edition, which runs on Linux One or Linux on Z. Both offer the same ability to provide a virtual ZOS environment on demand. It's only the underlying hardware which differs. Standing up PopUp Z Edition, or PopUp Z, is as simple as executing a few commands on your LPAR, and it's up and running in minutes. Once our PopUp is available, we want to populate it with our choice of applications and data, our own unique dev test environment to perform our task. We've built a banking sample application called NextGen Bank. This is currently built to show the customer transaction history in ascending date order, oldest first. There's a new request from a user who wants to see the most recent transactions at the top, which means the transaction history will need to be sorted in descending order. One important capability of PopUp is that you can take a snapshot of the entire ZOS environment and, at any time, return to any of the snapshots. This means you don't need to worry about potentially breaking your ZOS environment, as it can be reset to a previous state any time, perfect for testing out new features or upgrades. So before we do the code change requested by the customer, let's take a snapshot of this pop-up to save the before state. Here you can see the snapshot we just took. Now let's look at the development process. We will be using this pipeline to build, unit test and deploy our code change. It's a relatively standard CI/CD pipeline, and please keep in mind our choice of tooling is just one example or an illustration of what might be possible. Importantly, your own organisation's current mainframe ZOS delivery pipeline, and indeed any pipelines that you're planning to adopt, will work using PopUp Mainframe. As you can see in our example, we're using a standard IDE to do the development, then doing the build and unit test steps before deploying the code and running integration tests. Of course, there could be other phases in your pipeline, like security verification, for example. So let's make the code change. Let's check out the code from the GitHub repository using VS Code. Then we'll modify the query to retrieve the rows in descending order and commit and push the code back to the GitHub repo. The CI/CD pipeline is automatically triggered by the code check-in. This pipeline uses GitHub Actions, which in this example builds the code using the IBM DBB facility, then conducts unit tests using the open source tool COBOL check. Here you can see the results of the unit test. Then it pushes the compiled binaries into an artifact repository called Artifactory. These binaries are then deployed onto a different ZOS instance using IBM's deployment facility, WASI Deploy, where integration tests are performed using the Galassa open source testing framework. And as you can see, the Galassa test packs have reported an error. Looking in the UI, we can see that the balances are now blank. Now, as it turned out, the developer had overlooked some logic which was there for testing purposes. In situations like this, it's very useful to be able to go back in time to a previous state and restart from there. Let's use the PopUp Rewind capability to rewind our entire ZOS environment to the snapshot taken before we started the code change. We can see that the rewind has worked because we're now looking at the previous state. See the transaction history still in ascending order. Okay, so let's now go and fix the logic error. This time we'll make the code change using IDZ. With PopUp, developers can easily choose their preferred development tools, whether it's ISPF based or GUI tools. Now the code has been fixed correctly, let's commit the changes back to GitHub, which triggers the pipeline. The pipeline runs again, and this time all the steps pass. As you can see, the order of the transaction history has now been changed to support the user request. We've successfully developed and tested the customer change. Now we have deployed a mainframe code change using automation. Let's see how we can streamline operations and simplify the management of our mainframe. Ansible playbooks, as you might know, enable automation of tasks across multiple systems. PopUp Mainframe comes with pre-built Ansible playbooks out of the box, designed to make operations and maintenance tasks a breeze from the start. Here we're running an Ansible playbook to create a new RACF user on a PopUp, and a playbook to delete a user. All playbooks can be run on multiple remote systems simultaneously without requiring any ZOS knowledge or dependence on your RACF administrators. Another useful facility of PopUp is that it can be shut down just as fast as it's stood up. It means no environments are left running idle and no wasted resources. Really good for meeting IT sustainability objectives. So let's return to our pipeline diagram. What you've seen is a commonplace and obviously simplified application development process, all running under the PopUp Mainframe environment. As a developer, we've made a code change, committed it to GitHub, and kicked off an automated pipeline, which performs build, unit testing, deployment, and integration testing using a variety of third-party and open-source tools. We've also reset to a previous state of ZOS, then rerun the pipeline, which provides a powerful and efficient way to test out changes without the effort or delay of environment setup work or conflict with other activities. You've seen it's possible and very easy to establish an entire mainframe CI/CD cycle using your choice of tools, highly automated, offering an extremely productive and flexible process, all taking place within a virtual mainframe environment, the PopUp Mainframe product. This highly dynamic process is available at the click of a button to offer a dramatic improvement in how mainframe change is delivered. PopUp Mainframe is there to model your mainframe delivery process and can be used to help you innovate the improvements that you might be looking to make. PopUp Mainframe also delivers ready-made automation to codify operations and management tasks and enable those tasks to be performed by anyone. You no longer need to rely on other teams or follow approval processes to do routine activities such as environment configuration, dataset management, user management, health checking, and much more. Pre-built Ansible playbooks are shipped with all pop-ups, and we're developing new playbooks all the time. Check out our GitHub repo for the latest versions. What you can achieve with PopUp Mainframe depends on your own objectives. Customers using the product today have reported up to a 400% increase in mainframe deliveries made, a big reduction in the average time taken to deliver, significant sustainability metric gains by being able to switch off unused resources, and greater flexibility and responsiveness. PopUp Mainframe revolutionizes mainframe delivery by providing teams with an immediately available, fully functioning mainframe environment. This enables faster deliveries with greater flexibility at greatly reduced cost and risk. The PopUp Mainframe solution also supports organisational sustainability efforts through a lower carbon and emissions footprint. If you're curious to know more about anything you've seen in this video, contact us through our website or at popup-mainframe.com.